Let us see the clipper circuits today. The clipper is a circuit which clips or removes the portion of the input signal without distorting the remaining part of the waveform. So that is the basis of the clipper actually. Without distorting the remaining part of the waveform means if it's a half wave rectifier is a form of a clipper. Okay, so what is the application of a clipper? So clippers are mainly used for wave shaping and various other operations. So class A amplifiers, class A B amplifiers, class B operation, class C amplification, all the different circuits can be classified in some form of the clipper. So clipping action is required in various operations in electronic circuits. So we may have to clip the positive part of the signal, we may have to clip the negative part of the signal, we may have to clip certain click the waveform in a certain way and so on, and there is actually no end to the clipper. But let us see what are the two main categories of the clippers. That is, we have series clippers and shunt clippers. Now let us see them one by one. So let us see first the series clippers. Series clippers means, so what do you mean by a series clipper? So again, series clippers will have two parts, that is series negative clippers and series positive clippers. So series negative clipper means diode is in series with the load. So this diode is in series with the load and the output voltage is taken across the load always. See, it is called series negative clipper because this clipper is going to clip off the negative part of the waveform. So since it clips off the negative part, it is called as a series negative clipper. Now how it actually happens. So let us see how this works. This is a very simple circuit, one diode and one resistance, and if we closely look at the circuit, then it is nothing but a half wave rectifier. The only thing that is missing is that there is no transformer here, but directly we have shown V in, so this is nothing but a half wave rectifier. So let us see that. So this is the waveform for the circuit. So what we have here is that we have an input signal. So we have an input, and it has got a certain form, that is, this is nothing but my input, and of course we have a common reference, that is 0, and what we have here is Vm, so that is the maximum, and on this we show Vi. So we have the input, that is Vi, and then which is sinusoidally varying. Now as we can see that there is a diode, so diode has got a forward voltage drop of 0.7 volts. So if we can just show that forward voltage drop of 0.7 volts in the input voltage itself, we could show it somewhere here, that is 0.7 volts. So this level is 0.7 volts. Okay, so what happens is when the input crosses exceeds 0.7 volts, we start getting an output. So this was our input waveform, and let us see now how the output waveform will look. So just exactly below that we will have an output waveform, and again we have a 0 reference, and then what we can see is that when we project these two small points on this axis at this place somewhere down here, whatever remains above is going to come across the load resistance. So the diode conducts only above zero point 0.7. So that is what this circuit means. So diode conducts only above zero point 0.7. So that can be shown in the input characteristics as follows. So if this is the output, this is the input till 0.7, till input reaches 0.7, output is 0, and once the input exceeds 0.7, the output follows the input. So this is a very simple clipper. So similarly, what we have is a series positive clipper. So in the series positive clipper, diode is in series with the load, clips the positive part of the waveform, and if you can see that the diode polarity is exactly now reverse. So we have here VF, which is equal to 0.7, and since the polarity is reversed, it is minus 0.7. So what we can show here is that if this is the axis, and again if we consider a sinusoidal waveform, then what we have here is a sine wave, and instead of showing a line at 0.7, we show that at minus 0.7. So the line is going to be here, and once we project these lines on the output side, so what we get here is the output signal. That is, initially when the output reaches minus zero point 0.7, the output follows the input, and then what we get here is again the negative part of the input. So it's very important, that is this zero point 0.7 is there. So there is a 0.7 volts factor everywhere. So we need to project these points, on the output axis. So these are the points. So these points, when we take it on the output side, that point onwards it starts conducting, and output follows the input. So if this is V in, and if this is minus 0.7, then we say this is my V out with 0 reference. And of course this axis has to be the time axis. So this is a series positive clipper. Now how can we see this graphically? That is, input output characteristics is this way. So if this is the output and this is the input, below minus zero point 0.7, the output V out follows the input. So that can be shown graphically in this particular way. Then we have a special class of clippers, that is, now we have seen the series negative clipper and a series positive clipper. So if now there is a bias in series with the diode, so we can have two types of bias. So here in the first circuit in figure A, we can see that we have a bias in series with the diode, and in the second circuit the direction of the diode is the same, but what is reversed is the polarity. So if this bias is not there, then we say it is a negative clipper. If the bias is there, then we say it's a series negative clipper with a DC bias. And in that also we can have two types, that is with a polarity and with bias with a reverse polarity. So how is the effect of that? So what we can see is that first let us see the input output characteristics here. So input should now follow the output should now follow the input only when it overcomes V and it overcomes V volts and 0.7 volts. So when it covers V as well as 0.7, the output should be equal to V in. Below V plus 0.7, this value is V plus 0.7, the output should not follow the input. So that is what we actually want. Similarly, in the second circuit the bias is reversed. So now V in has to overcome minus V. It has to overcome minus V plus zero point 0.7. That is why this point is now the output follows the input beyond minus V. So instead this point now shifts on this side, that is shown in this figure. So this is the input output characteristics for the first one, and this is the input output characteristics for the second one. Now let us see this same figure A and figure B graphically. So this is the waveform for that. So in the first waveform we can see that we have a sinusoidally varying waveform. So sinusoidally is the same. So with respect to a sinusoid only, we are going to plot all the waveforms. So we just draw a sinusoid first, and again when you project these points, so that is going to give us output. So the output can be in two parts, that is for the figure A, and then we have the figure B. So what we do first is, so we can just see this carefully. In figure A, my voltage is V plus zero point 0.7. So I show V plus zero point 0.7 here. So I name this level as plus V plus 0.7, and just below that minus V plus zero point 0.7 is going to be a negative voltage level, because minus V is much greater than 0.7. So we have minus V plus 0.7. So we can see that we are having two. So figure 1 is working with this level, and figure A, or figure A works with the first level, and the figure B works with the second. It is a negative clipper. That means in figure A, everything that is below the level is going to get clipped off. Okay, and in figure B, everything below this level is going to get clipped off. That is why what we get here is, for figure A, we get, when we take these points, so these are the clipping points actually, and so these points are for, this is figure A level, and these points we need to project them in the figure B. And of course all this is with respect to time and so on, and what we can show here is again a VM, and this level is nothing but VM. Okay, so when we look at the figure output of figure A, that is we have to project these points on the output characteristics, and whatever is left above this is going to appear, and let us say that the time period is t1 to, let us say, t2. Again, till it reaches this particular reference, it is, the output is going to remain 0. So what we are going to get here is this level, and then again we have this as, so, and then again we can just draw this. So this repeats continuously, and that is what we say, that the output of the figure A is going to be this particular way. Okay, now similarly, the what will be this level, V minus plus V plus 0.7. So this particular amplitude will be Vm minus plus V plus zero point 0.7. So that is slightly mathematical in nature, and that is how it is. Then we have figure B. So for figure B, this is the reference, and everything below that is going to clip. So we have these small peaks which are going to get clipped off, and as a result the output waveform is going to take this particular shape. So first we need to project these points here, and of course again these 2 points shall be projected on figure B. And once you do that, we can have a level here. So that is, so this level is minus Vm minus V plus 0.7. And let us just show this clipping. So that is how you draw this, and this is the zero reference, and again you can show the amplitude axis, and here we have the time axis. So that is how it is going to be in the case of the two clippers. Okay, so it's a negative clipper. So first we draw the references and it clips everything below the reference. In the positive clipper, it is going to clip out everything above the reference. So it may have, we may have two different biases, but the clipping is always above in the positive clipper, and in this case it is always going to be below. Okay. Similarly, we have a series positive clipper, so you can see that the diode polarity is again reversed, and we have two different conditions depending upon the bias. So now in the first case, the output, before we get some output, the input has to overcome minus V, and so it has to overcome plus V and minus 0.7, and here it has to overcome minus V and minus 0.7. So that is why we have 2 points, plus V and minus 0.7, and here we have minus V and minus point. So there are the two output characteristics. So this is how the output characteristics look, and these are the 2 points for the figure A and figure B. So now let us look at the waveforms again. So the waveforms are similar, but now we have a, let us draw the sine wave first, and this way, and so again we have two references, that is plus V minus 0.7. So that's going to be again greater. Then we have the second reference. So first reference is plus V minus 0.7, so that is going to be positive. This is going to minus V minus 0.7, so that's going to be negative. Again we have some reference points. So this is, remember, a positive clipper. That means it is going to clip everything above the reference. So when you clip things above the reference, what you get in the first case is this portion gets clipped off. So we have Vm, so this portion is going to get clipped off, and everything below that remains. So this is the output for figure A. And similarly for figure B, below, everything above this level is going to get clipped off. So what we get here is two small peaks, and the level corresponding to this is, so this is plus V minus 0.7, and then we have Vm somewhere over this, then we have minus Vm minus V. So that is this particular voltage level. And this level is minus Vm. So similar, but now just the positive part is getting clipped off above that. So reference is there, above that is positive, below that is negative. So the above part is getting clipped in the positive, and hence the name positive clipper. Now we have seen different class of clippers. So that is nothing but your series clippers. So the next part is the shunt clippers, which we will see next time. So shunt clippers.